So 3.4, guys, the chain rule. Alright, so far, all the rules that we've talked about in class have been dealt with the four basic operations, right? We've talked about addition, we've talked about subtraction, we've talked about multiplication, we talked about division, right? So we know how to take care of differentiation with those. So we have the product rule, we have the quotient rule, we have the power rule, right? And then we have the sum and difference rule, so we can apply it a whole bunch of times, right? Remember that? Okay, so today, we're going to deal with things such as, well, what if you have something like this? Or this? What do you call that? Composite functions. So we're going to talk about how we can take the derivative of a composite function. Okay? Now, before we get started, I need to make sure that you know how to decompose a function. So we're going to go back to pre-calc for a moment, just to make sure that you know what I'm talking about. So let's say that I tell you to find two functions. So find two functions. We're going to call it f of x and g of x, such that f of g of x is equal to h of x. Okay? So we're going to find two functions, f of x and g of x, such that f of g of x is equal to h of x. Cool? So this is just pre-calc. Sorry, those pens are bothering me. Like, it's too light. It needs to be a little darker. Alright, so let's say very first example. So A. There you go. That's better. H of x is equal to the square root of x squared plus 9. Alright, so we're trying to decompose this. We're trying to come up with two functions that would compose h of x, right? So that means we're looking for f of x, and we're looking for g of x.
So f of x will square root x, and then g of x equals square root x.
Cool. So g of x, as you can notice from here, g of x is what's on the inside, right? So the easy way to look at this is what's on the inside of the square root?
Wait, could you also
X
do,
squared plus 9, right?
could you also do f of x is equal to square root x plus 9, and then g of x equals x?
Yes. Okay, so that's on the inside, right? So what's on the inside of the root is x squared plus 9, right? What are you left with? A root of something, right? Well, we got to represent that something by a variable, which in our case would be x. Well, how can you check that these two actually work for that?
You plug in
Actually do the process, right? So f of g of x, so that means f of g of x, that means in here I would have to plug that in, and what do you get? The same thing. Now, when you're doing the chain rule, some of you guys may see different things. I recommend that you go with the most obvious one. In my opinion, I know it's sometimes it's subjective, because you're like, well, this might not seem so obvious to you. Some of you guys might have seen this, okay? So this could have been another option. So f of x equals to, you ready? Square root of x plus 9. And called g of x as x squared. And there's nothing wrong with that. However, the process in which you then derive will become a little different, okay? With practice, I think you're going to be able to see what most of the class will see, okay? So, to be honest, I would probably go with the first one rather than that second one there, okay? Alright, so B. Let's see if we all can get the same thing. So, h of x is equal to sine of 2x. I need an f of x, and I need a g of x. So try it on your own, and then we'll go over it together. So think about it. So g of x is what would be inside of a function. Cool? Alright, what do you think, Zach? What do you think g of x would be?
I know g of x is 2x.
Sweet. And Josh, if that's if g of x is 2x, then what would f of x be?
Sine.
Very good. Sine of x. Cool? I really don't see another option for this one, to be completely honest. Can you think of another one? I can't, honestly. Good? Alright, we're going to practice some more. So, C. We're not doing calculus here, right? We're just decomposing stuff. Okay, so C. Let's say that you have h of x is equal to e to the power of 5x plus 1. We need f of x, and we need g of x. Right? Alright, Jada, what do you think, man? What do you think a good g of x would be? Okay, so if we make that g of x, Melissa, what would f of x be? E to the x. Cool? Alright, one last one and then we'll move on. So, D. Let's say that h of x, we're going to make that equal to the natural log of x divided by sine of x. Cool? Alright, Piyush, what do you think would be a good g of x for this one?
X over sine x.
Good, x over sine x. If that's what our g of x is, Sydney, what do you think f of x would be? Very good. Do you feel pretty comfortable decomposing? Yes? So we're ready to then go on to calculus. Alright, fantastic. So now that you had some practice with decomposing, we can now jump into the actual chain rule. Ready? So here's what the chain rule says. So we got the chain rule. What does that say?
Derivative of something with respect to x.
Derivative with respect to x. So we need something, right? So that something is going to be obviously what we've been working with. Some kind of composite function. So in this case, I'm going to call it f of g of x. And here's how it works. You are going to take the derivative of the outer function. Cool? The derivative of the outer function and multiply by the derivative of the inner function. So f prime of g of x times g prime of x. Cool? So we're going to practice this. So example 2. We're going to differentiate. Alright, let's say that you have something like f of x is equal to the square root of x squared plus 1. Okay? Alright, do you see how we can decompose this problem? Agreed? Now, I don't expect you to show all this work, but let's say that we're going to decompose it into two functions. Okay? If I was to decompose it into two functions, and let's actually switch the name of this. Let's call this h of x so I can switch it into an f of x and a g of x. Cool? You guys with me? So, let's say that I have f of x, and let's say that I have g of x, and let's again say that h of x is equal to f of g of x. So, just like we were doing on the previous example. You guys with me? Okay. What would be g of x in this problem? X squared plus 1, right? And what would be f of x? Root x. Okay? You guys with me? Now, if you look at the definition, it tells you, hey, take the derivative of the first function, right? Are you confused by having this g of x on the inside? A little bit, right? You guys agree? So, I want you to ignore for a moment and just pretend that that was an x, right? So, you're taking the derivative of f of x. Cool? What's the derivative of this thing? Well, as it stands, we have a problem. Because you need to rewrite it like this so maybe you can see it. Agreed? You guys with me? Okay. If you take the derivative of f of x, so that would be f prime of x, right? What would it be?
1 over 2 squared x.
So 1 over 2 x, like this, right? And I agree, and we can simplify then a little further to say that f prime of x is equal to 1 over 2 square root of x, right? You guys with me? Now, what is the derivative of g of x? 2x, right? Okay. Notice how we kind of, and I say kind of, have done what the formula told us. Sort of. Agreed? You guys with me? We have some derivative f prime, right? And then we have g prime. Yes, sir.
I was saying now we have to use the multiplication rule.
Not necessarily. Just we're just gonna multiply here. Okay. So here's what's gonna happen. I'm gonna go down here so I can have some space. So you guys with me so far here? Okay. So I'm gonna say, hey, h prime of x, which is what I'm doing here, right? I took f, right? Which in our case, and I took the derivative of it, right? So this is the derivative, agreed? 1 over 2, but look how I'm going to write it, okay? 2 times the square root of, and I'm going to leave it blank. Because this is in terms of x, agreed? But if you do composition, remember, everywhere you see an x, you plug in whatever they ask you, right? So what's going to be there instead of x? X squared plus 1, right? Because that's what g of x is, right? G of x is x squared plus 1. Agreed?
Instead of a 1 on the numerator, we just put 2x.
Yes, and we're about to do that here in just a second. Notice that once you have this right here, you have to multiply by the derivative of g of x, which in this case is 2x. Right? Now, if I clean this up, I would then say that this is, the 2's can cancel away. Agreed? X divided by the square root of x squared plus 1. Now, I would just leave it there. I know that from the past I've told you don't leave square roots in the denominator. I know. But you're not going to have time to clean things up on the exam. You're okay there. Like, the calculus is done. If you wanted to, you're welcome to take care of the square root and bring it to the top, but you're going to be okay if you stop there. Okay? Now, I don't like this, the way I've explained this here, because it gets really confusing in my opinion. Let me show you how I think this through from the beginning. I just wanted to show you how everything came into place with the formula. We're going to do the same problem, but I'm going to do it a little differently. Okay? So, h of x, I'm going to rewrite it. So if I rewrite it, instead of having the square root, you would have x squared plus 1 to the 1/2 power. Agreed? Yes? One more time, do you still see how there's a function within a function? Yes? Can you recognize that there's an outer function, and this outer function would be like x to the 1/2 power? You guys agree that? Here's what it does. So remember how the formula tells you, hey, take the derivative of the outer function? That's what I'm going to do. You ready? Wouldn't this be x to the 1/2, which is just the power rule? So wouldn't that be just 1/2? And I'm going to pretend, and I know in the camera you can't see it, but x, right? Our x is x squared plus 1, right? X, and 1/2 minus 1 is, right? Stay with me. So 1/2 times that is just a power rule, right? Subtract 1, cool, and leave this alone. Agreed? Now the formula says whatever you have on the inside, you leave it alone. That's why I'm leaving it alone, right? And then it tells you to do what with what's on the inside? Take the derivative. What's the derivative of x squared plus 1? Now, if I clean this up, do you think I'm going to get the same thing? 1/2 times 2 is just 1, right? X divided by the square root of x squared plus 1, which is the exact same. This is going to take some practice, guys. Okay? So I'm going to repeat what happens here. I want to, for the moment, you're going to pretend, and I'm going to write over this. For the moment, you're going to pretend that this right here is just x. X to the 1/2 power. Agreed? If you take the derivative of x to the 1/2 power, you're going to use a power rule, right? So 1/2, you bring the 1/2, right? X, 1/2 minus 1 is negative 1/2, right? But you didn't have x, you had x squared plus 1, so just keep the x squared plus 1, right? Now the only thing you got to do with the chain rule is whatever you had on the inside, you got to get the derivative of that and multiply by what you had. So in this case, x squared plus 1, the derivative of that is 2x, multiply by what you have and clean it up. It's going to take some practice, okay? Ready for another one? Alright. Example number 3. And we're going to do some of this together, and then eventually you're going to try to do some of this on your own. So f of x equals x squared plus 1 to the 3rd power. Now the instructions are the exact same we are going to derive. So f prime of x. Once again, do you see an outer function here? That would be x to the third power. Agreed? So I can say the derivative of that would be what?
It'd be
3
x squared plus 1 squared.
x squared plus 1 square. Agreed?
Yes.
Yes? Times the derivative of the inside, which in our case would be,
So it'd be 6x cubed.
so 2x, right? So the derivative of this would be 2x. Agreed? We clean this up a little bit, so f prime of x, well, 3 times 2 is 6x, and just leave it like this. Don't go any further, please. Don't waste your time. Don't try to expand x squared plus 1, okay? Do you guys see that this is technically the power rule with just one extra step? Making sure that you get the derivative of whatever's on the inside? Did you know that the power rule is actually the chain rule? I want you to think about it, okay? So I'm going to pause the video here for a second. Okay, sorry about that, guys, and that you're watching the video, you didn't get to see that example, but you'll be okay. Alright, so now you're going to practice this on your own. I'm going to throw some up here for you to try, okay? And I'll be walking around to help you out. For those of you watching the video, go ahead and pause it after I write the problems down, and then hit play when you're ready to check your answers. Alright, so here's the next problem. So let's say that you have g of x, so this will be example number 4. G of x is equal to 3x minus 2x squared to the third power. So we're going to differentiate that. And then, while you're at it, you can go and do example 5. We can say that f of x is equal to the cube root of x squared minus 1 to the second power. So I'm going to give you 3. And last one, example number 6. Let's say that I tell you that f of x is equal to negative 7 divided by 2x minus 3 squared. Okay, so that's the 3 examples that you have. So if you're watching the video, go ahead and pause it and hit play when you're ready to check the answers. Alright, so I'm guessing if you're watching the video, you've already tried this on your own. So here's for you to check your answers. So the very first one, the answer should be, if you kind of simplify things out, so if you got about this far, you should be okay. So 3 times 3x minus 2x squared times 3 minus 4x. I went ahead and distributed this 3 with this binomial here, so that I can get 9 minus 12x times 3x minus 2x squared. After that, I'm really not going to do anything else, because it's just going to be too much, honestly, too much algebra. So I'm going to just call it a day there. On the second one, I went ahead and rewrote this cube root into a 2/3 power to make it easier. So by doing so, then I get 2/3 times x squared minus 1. Well, 2/3 minus 1 is negative 1/3, and the derivative of the inside is 2. I don't want to leave anything with negative powers, so I went ahead and rewrote this as, well, first of all, 2x times 2 will be the 4x that I have here. The 3 stays on the denominator, and then this negative power brings this down. And I don't like fraction power, so I turned it back into a cubic root. Okay? Last one was negative 7 divided by 2x minus 3 squared. I rewrote that as negative 7 times 2x minus 3 to the negative second power. So now I can use the chain rule and the power rule really here. So negative 2 times negative 7 is positive 14. 2x minus 3. Subtract 1, so I get negative 3. And the derivative of the inside would just be 2. 2 times 14 is 28. And bring this down because it's a negative power, so 2x minus 3 to the third power. Okay? We will not be finishing this video today, so if you're watching this, then make sure that you watch part 2.
Find out on the next episode.
Find out on the next episode, okay? So that's all I got for you guys today, okay?